I was using cron, and I was thinking about airflow. And I actually came to Airflow talk ages ago. That was part of this group, like a really long time ago. And after the talk, I thought, it sounds cool, but it sounds complicated. So this is what I thought in my mind. I thought value, cron tab was over here. Pretty good value, not very expensive. And airflow, I thought, was way out here, okay? Airflow, but in reality, now I'm going to tell you that I think it's more like this. With it actually costs less to use airflow, and it costs way more to use cron tab. So you might say cron tab is like simple to install and simple to use, but the logging and dependencies and debugging is just so hopeless. So the things that scared me away were like these multiple processes for airflow and thinking about having to set up a DB. It just seemed like a bunch of stuff, but you get all these benefits. So how do you set it up? Well, cron tab looks like this crap up here, which is just some, if anyone's ever used it, you put in the time that you want things to run, and then this command, which is super hard to debug after that. And then you have, if you're me, you make all sorts of crappy logging systems, and you try to figure out what happened after the fact. And in Airflow, you would instead write a bit of Python code, which puts the crappy command inside a bash operator, and then you can connect the tasks like this to declare dependencies. Here, you're worrying about dependencies by, you're handling dependencies by timing things, like saying, oh, by that time, that should have finished or something. It's insane. So running Airflow looks like this. I had some trouble with my DAG the other day, and this is what it looked like. And so it's very clear from this what exactly it was that failed. The red square is what failed. So a full run is like down a column down this whole thing, and this shows the dependency between the tasks. So this task had trouble, and that meant that all of these were dependent on that, and it didn't make sense to run those. So that's pretty smart. You can click on any of these squares, and you get the full logs. What happened for that little task? I mean, it's super simple stuff, but wow, does that ever make things easier? So instead of paging through these ridiculous logs on the right, or grepping, or whatever horrible thing you would use, you just get to jump right into what happened for that one process, and you get right to the issue and you fix it. And it's easy to go back in time and, did something change from last week? All the different tasks give you run times, and that can be super useful if you see some runtime changing a lot, or just trying to figure out why the things take so long. Yeah, that was painful in cron. I did some really weird stuff back there to try to get that. So there's Airflow has this notion of executors, like this kind of the structure over here. So you have the web server UI. That's what the UI we were looking at was in the web server, but there's the scheduler. Those two main components, the scheduler and the server, and then there's different types of executors that can scale up to running your whole enterprise thing. But I'm using just local, and it works actually really well. Yeah, by default, you get sequential executor, which can just do a single task and writes to SQLite 3, which doesn't handle parallelism. So if you just simply upgrade to this one, it's actually pretty good. If you want to get fancy, you can run Celery and have many servers working. So I set up some simple bash commands to help manage it, to show the status, to start and stop. And this is basically just starting and stopping both the scheduler and the web server. Looking at the log, that's not really needed unless there's a problem with Airflow itself, which has been pretty rare for me. Yeah, so the question is, if someone wanted a horse, would you give them a plush toy with a stick in it? No, that would be mean. If someone needed to use a car, would you give them a vehicle with no wheels? No, you would not do that. That would be rude. So in the same way, you can't choose Luigi or Azkaban or any of these other crappy choices if you need to deal with scheduled tasks. It just doesn't make sense. It just doesn't. I thought Airflow was for these really big projects. I thought it was only for them, but now I realize that it's actually super useful even for the smallest, stupidest project. There's no project too small for Airflow. That is what I'm going to tell you. today. If you choose, depending on what you choose, you could be on two very different trajectories over time. And I think that at first you can be a little bit happy with cron tab because there's no install, but you'll get over that within about a day. And after that, it's just all downhill. So you can eat the happy salad. You want to eat the happy salad. So choose the happy salad. That's my talk. The only thing I'm going to shill is my podcast. And link me on Twitter or whatever you like. It would be very nice to meet you. Thank you.
All right. Nice. Short and sweet.
Was I in time?
Yeah, you were. So as the host, I get to go ask the first question. Do you know if it works on all OSs? I noticed that it seemed to be mostly Ubuntu or some form of Linux.
I'm sorry, I actually have no idea about that. I don't pay attention to other OSs for very many years.
I think it's implemented in Java, so sure.
It does say that it works in the website. It says Windows, Mac OS, and Linux.
Cool. Thank you.
Nice.
Yeah. Also, if it doesn't work, you could always just Dockerize it, and that's a pretty standard way to use Airflow.
Yeah, you can install Airflow with pip. So as long as you have pip, it's a Python package, and everything is kind of written in Python. So as long as you have a good Python environment, and also Docker and Minikube are really good ways. So if you don't want to mess with like the Celery executor, you could use the Kubernetes pod executor to have like concurrent runs of your workloads or different kind of things, so that you don't have to use the serial or the local executor.
Awesome. Thank you.
Anyone else have questions?
I have a question. How well would it work if you're using it across the whole team, rather than sort of just scheduling your own stuff on your own computer? Like if you were to share something like an EC2 instance and have Airflow running on that, would that work, or is that just not how it's designed?
Well, you can have more than one DAG. And so if I go back to, so this DAG is a whole chain of things that are all related to one thing, rebuilding part of the
You
data
need to
warehouse.
share your screen.
Oh, sorry about that. So you can have any number of, but anyway, you can have any number of DAGs. So that's how I would organize it. If I like, so it's basically like one DAG is like a line on a cron in a cron tab. So it would be very easy for you to have a set of DAGs and for another developer to have, or data scientist or whatever, to have their own DAGs that are just scheduled with the same central system, but they don't necessarily need to, besides that, interact. I think that would be a pretty sensible thing to do.
Yeah, and you don't need to worry about dependencies too much. Or there is that problem that you do have to worry about dependencies, but you could do something like create a process which is within its own environment. Or again, is that not how it works?
Yeah.
Almost
Robin,
containerized.
Oh, sorry. Yeah, so if you think about like the Kubernetes pod executor, right? Usually if you have like the bash executor, then it will go and execute a bash command on the host that Airflow is running on. But you can have like a Docker executor, a container executor, or a Kubernetes executor that will execute a pod, and the pod can have a container image defined to it, and that image can have that specific environment that you need. So if you have like two different processes that has like the same dependency, but different versions of the same dependency, then you just run the same DAG that points towards the Kubernetes pod operator that will spin up the pod that will have those dependencies baked into the image. So really instead of using like a bash executor or like a Python executor that runs on the local host, you're using the executor to run a container to keep track of that process running, essentially.
Awesome, thanks.
Yeah, no worries.
Sorry, Robin, I had a quick question. Sorry if it's a naive question, but since it's a DAG, I'm guessing it doesn't allow cycles. How do you deal with, I would imagine in any realistic workflows, you would need to revisit some nodes. How do you allow that?
I don't know. That sounds like a bad idea, having cycles. I've never needed them, but I'm trying to understand what.
Well, don't you need to iterate? Like you do something and then you go back, and maybe there's a better way of capturing this as a DAG, but.
Oh, I see what you're saying. Yeah. You can have like chains of things. If you need to do something 3 times, you can repeat it 3 times. I don't know if that's what you mean.
I guess.
Yeah, I think you're trying to avoid cycles in this case, because you can have nodes that separate. Like this task has 2 children, and then you can join them later, but that's still a graph, right?
Yeah.
Without cycles.
So,
And Shah, thank you for your answer. I'm learning a lot from listening to you. So you obviously are using it in a much more advanced way than me, which I think is cool.
Yeah, we have it deployed at our work, in the work that I do.
That gives me faith that I can grow with it over time, because right now I use it in a fairly simple way, and it's quite useful in that way.
Also, just an FYI, you can kind of have cycles in your DAGs. I mean, it's not ideal, but when because Airflow has the concept of like retries, I mean, like everything else. So, you can kind of say retry this thing 3 times. If it fails, just don't do it anymore. So technically you can create cycles that way. But yeah, but really when you're creating DAGs, it should really be like one thing that finishes. It should never be unending, because then you will never get to see all the great UIs that Robin was showing. Oh yeah, this finished, and this ran again and finished. So you kind of want that.
we should probably actually say what a DAG is.
Robin?
Okay, so it's defined as directed acyclic graph, which is just a graph, which is like a network, which is directed. That means that the notion of nodes having arrows to other nodes, the arrow meaning a direction, and acyclic meaning that there's never any, you can't follow any arrows back into a loop. So it's just a little more general than a tree, I guess.
If you come to the meetup next week, you're going to hear a lot more about it.
I want to ask another question. What is the sort of story here for fault tolerance? What happens if you have a node that fails that may not strictly be necessary?
Well, according to there's probably people in the room who know this a lot better than me. I'll take a really brief stab at it. Is that it respects the dependency tree, so that if something fails and other things don't depend on it, they can still proceed. But things that you have defined as dependencies, the semantics are that means that those cannot proceed if that node if that task fails. If you're talking about a node in terms of a server going down, I actually have never run it in with any fault tolerance. There's a retry mechanism, but that's fairly simplistic. But yeah, I run in a simple way, assuming my server's not going down. And Shah probably has a lot more to say.
Sure. Definitely. So it is very fault tolerant in the sense that it has like 3 kind of components. There's the web server, which you can use to kind of define your DAGs. There's a scheduler that takes the definition of your DAGs and then runs it on a schedule. And then both of those things has a persistent state in a database, and you can define the database to be any kind of a database. Most people go with Postgres. So within the database, when you're running a DAG, let's say it's running on a node, and then it's at a certain task, and then the node fails. If that task doesn't report back its state and persisted to the database, that means the next time the web server comes up, it's going to check that, hey, is this DAG complete? And then the scheduler is going to be able to schedule it properly. So as long as you have multiple nodes that can come up with those scheduler and web server services, then it's fault tolerant.
Awesome. So there is probably time for 1 or 2 more questions, if anyone has one.
I have one if no one else does. Yeah. Robin, did you also look at other, like, if you were just, if your goal was to just use it for like cron jobs kind of things, or did you also look at things like, I don't know, Jenkins or, like tons of other things? Like what made you pick Airflow?
I looked at a bunch of things, but I didn't really get into Jenkins. I did look at Luigi and installed it and tried it, and I tried, but everything just looks so much worse. And also I love Python, and I don't really want to deal with Java or any of those other things. So that really affected my point of view. And I also already used some other Airbnb product, Carvel or Superset, and I liked how their stuff worked. So did you pick it, Arnie, or this is already using it at work?
Yeah, I think both at my current work and past work. Yeah, we use Airflow quite a bit. But yeah, we also, for whatever reason, we also use Jenkins. We also use like tons of other things because, well, why not? Just use everything and then cry about it.
Matt, is there time for one more question?
Yes.
I wanted to ask Shah what things you hate about Airflow.
There's quite a bit. So usually, if you need a fault-tolerant system, then you need to have it running on something like Kubernetes, which we do at our current work. And when you have it running in Kubernetes, you have to have these horizontally scaled schedulers. And then you need to define the worker pods that run those processes that you're scheduling. And because you need to have your system kind of expand and contrast as needed based on the workload, there's a lot of kind of adminning work that needs to be in place to kind of have that in place. It would be true for any other system. But if you think of something like EMR or a compute instance, like a HPC high performance compute instance that you can spin up in AWS, those things are fairly elastic without having to kind of do a lot of those adminning for that. For Kubernetes, there really isn't a really well-defined way. GCP supports Cloud Composer, but Cloud Composer under the hood is just a Kubernetes deployment, and you get charged an extra fee for using the Cloud Composer version of Kubernetes as opposed to using Kubernetes directly. So yeah, it comes with a lot of adminning things if you have like multiple teams using the same system.
All right, that is all the questions that we can have, except for I gotta ask one more. Was there any tutorial that you went through that kind of taught you how to do Airflow? Like, how would you start if you wanted to
I think the docs are pretty good and it's really simple to install. So what I would just say is just don't be afraid of it. Just power through it and feel free to ask me questions if I'm not going to volunteer, Shah, but yeah.
Yeah, go ahead. I'll actually post a blog post that I have on Dockerizing Airflow from Kapsu in the chat.
Awesome. Thanks so much, Shah.
Perfect.
Yeah, no worries.
All right. Well, why don't we jump to Robin Y? And before you give the presentation, just be sure to say who you are. It's very exciting to have you here.
All right. Hi, everyone. My name is Robin, and I'm a student. I'm interested in mathematics and machine learning. I'm here to give my talk on fire detection and drone automation for monitoring wildfires. So, as you're probably aware by now, wildfires have become a very increasingly devastating problem in the province. And just last year, over 300,000 hectares were damaged alone by wildfires, costing over $200 million. So I wanted to see if there's a way to use deep learning and data science to help tackle this problem. So in my research, I found out that drone technology is actually becoming a very useful asset for wildfire firefighters. So drones provide critical monitoring information that can help firefighters reduce the damage caused by wildfires. So currently, drones are used to monitor the fire line, locate hotspots, map the wildfire, and provide a real-time aerial video feed of the wildfire to firefighters. So after reaching out to some local firefighters and seeing how I can improve this situation, I found out that human-operated drones aren't the most efficient allocation of a firefighter's time and resources. And they're really difficult to operate in high-stress situations, and they can put firefighters at risk. So I wanted to figure out how I can solve this problem. So I investigated a potential method for wildfire drone automation using object detection models for fire recognition. So specifically, autonomous drones would be able to fly along a fire line, map the burning area, and send data back to firefighters. So this will allow firefighters to do more important tasks while effectively obtaining the critical monitoring information they need to control and reduce the damage a wildfire can cause. So in order to perform this fire detection task, I web scraped around 3,000 RGB images of fire in various contexts, such as different sizes, angles, illumination, etc. And I tested 2 different labeling techniques for labeling the data. So the first method on the left side shows unsegmented labeling or segmented labeling, where each different flame or section of the fire is labeled as a separate object. And in the second method on the right, the entire fire region is labeled as one object, so which is called segmented or unsegmented. So, and furthermore, to increase the size of my data set, I applied data augmentation to existing images. I translated, rotated, and did some cropping and scaling to generate more data. I also tested whether applying hue, saturation, and value transformations to augment the images would increase how well the detection models can detect fire. So I created 2 different test sets of around 200 images each to test the trained models. The first test set consists of images of more simple or single flame fire, and the second test set is a more difficult detection task since it has more complex multi-flame fire. So that's on the bottom 3 images, and they're from emergency scenarios. So, and I use the mean average precision metric at an IOU of 0.5 to perform my tests. So I use the YOLO V3, so you only look once V3 tiny model, which was used to perform tests with the labeling and data augmentation techniques to determine which configuration would lead to the greatest mean average precision. So YOLO V3 has the smallest number of parameters and is the smallest model. So it basically, it has the lowest training time, so it's just more practical for it to run tests. So after conducting several tests, I determined that unsegmented labeling, so labeling the entire fire region as one object, leads to a greater mean average precision, and removing hue, saturation, and value augmentation actually increases the mean average precision. And this is most likely because labeling each flame as a separate object and applying HSV augmentation would probably create unnecessary noise and variance within the data, which would cause the model to decrease in performance. So that's why I removed HSV augmentation and used unsegmented labeling. So after the data set was configured, I tested a bunch of object detection models, such as YOLO V3, V4, and SSD. And I wanted to see which one would obtain the highest mean average precision. So after doing a bunch of testing, I found out that YOLO V3 obtains the greatest mean average precision at an 89.5% on the emergency fire test set and a 98.7% on the single flame fire test set. But YOLO V3 Tiny has the fastest inference speed at an average of 0.1 seconds per image, which is around 10 times faster than all of the other models. So it can perform inference in real time, meaning that you can actually port it onto a drone. So after I conducted all of the model training, I built a Unity simulation to model a fire front and a drone object to test autonomous flying. So the YOLO V3 model detected fire along the drone's path, and the drone was tasked to fly parallel to the fire front. So the drone analyzes the distribution of detected fire in an image and orients itself so the fire is on the extreme right or extreme left based on a threshold of the drone's view. And I tested different parameters such as velocity, angular speed, detection rate to see how they affect the movement of the drone. And I also actually implemented a drone automation system in real life using a GPS navigation. So an Arduino Nano, a GPS module, compass, and radio module were ported onto a DJI TELLO, and the drone sent its positional information and the video feed to a Raspberry Pi, which would perform the inference. And it displays all of the information about detected hotspots to firefighters via a Flask application. So overall, this is a really lightweight system for fire detection and can easily be ported onto existing drones. And this technology has the potential to help firefighters and increase the efficiency of monitoring wildfires. With automated drones, firefighters can focus on more important tasks while obtaining critical information that will aid them with the fight against wildfires and reduce the damage that they do. Thank you.
Nice, right on time. It's about to go off. Awesome. do you want to just quickly stop sharing just so I can see who's going to have questions? Because I'm going to guess there's going to be a few. Again, I'm going to take the first one. Future directions. What are you interested in developing? Have you talked to, say, the fire department recently? What kind of feedback did you get?
Yeah, so I actually reached out to a few fire departments and local firefighters, and they told me the main improvement that they would need is that the data would need to be in near infrared, because currently I have RGB images, and mostly they do their fire detection in near infrared, and that helps with locating hotspots. I just chose RGB data because it's just easily web scrapable and it's more accessible than near infrared. So I'm contacting fire departments and finding data sets that contain near infrared images of fire. Yeah.
Just as question or a suggestion, I mean, if you do switch to near infrared, you might not really need deep learning, right? The hotspots will be fire, so you can do it in an unsupervised way. Just something to think about, like you might not want to go down the whole labeling and the whole that route.
Yeah, I'm thinking about that, but some issues that might pop up is that the fire also makes other things in its like area also hot, so that would also appear up on the image. So you would actually some needs the outline of the fire to perform any detection.
So the idea would be that this drone would be autonomous and in the sense that the processing would be done right on it, not sort of tethered or wirelessly to a ground station where the processing happens. Is that correct?
Yeah. So usually it would be it could be implemented on like a phone or an iPad or a computer. Firefighters do actually carry them around, so it's a good like ground station for that.
Are you aware of a company in the Vancouver area called AeroSense? They do.
I haven't heard of them.
They were a startup a couple of years ago. I don't know quite where they're at now, but they were working on autonomous drones for inspection of hydro towers. It's just different application, but some similarities to what you're up to. It sounds like a very interesting problem for them too.
Yeah.
You may have covered this in your talk, but I think maybe I missed it. But do you have a list of like type of augmentations that you made that contributed to lift or didn't contribute to lift in terms of the performance of the model?
Sorry, I didn't quite catch that.
Oh, sorry. So do you have like a list of augmentations that contributed to the performance of the model or didn't contribute to the performance of the model in kind of generating a lift in the inferences?
Oh yeah, so the main issue I had with augmentation is just hue, saturation, and value. So all of the other augmentations I applied, they worked pretty well, and they increased the the mean average precision. But it was just hue, saturation, and value that was decreasing model performance, and that's probably not a good like augmentation to apply because fire is just going to be in a specific color range. So hue, saturation, and value, they're probably just adding unnecessary noise. So yeah, that transformation didn't really work well.
Cool, yeah, that makes sense.
Are you aware of the Wildfire Sat mission by Canadian Space Agency?
No, I haven't heard of it before.
So I'm just sharing you the link. So it's an initiative by the Canadian Space Agency. It's a mission to basically detect and monitor fires live anywhere in Canada from space. It's supposed to be launched in 2025. So MDA is also involved with it. But I would imagine your algorithms would be also very relevant there. So that's something you might want to keep an eye on.
Right. Thank you.
Mm-hmm.
Can I ask what you want to do next? Like, what do you think the next steps would be for you on this project?
Yeah, so right now I'm working on collecting near-infrared data. I'm working on optimizing the models. So what I'm doing right now is working on a knowledge distillation process as YOLO v3 or YOLO v3 as a student or a parent model and a YOLO v3 tiny as a student model. So it would just allow the models to run in real time on much smaller devices, such as a Raspberry Pi. And I'm also considering reaching out to fire departments later on in the year to do some actual live testing.
Thanks. Super cool talk. Thank you.
Yeah.
I have one question. So what I wonder is like how frequently are helicopters deployed in firefight? Like, I wonder whether that might be an issue. No idea.
Yeah, so it really depends on the situation because currently deploying helicopters is really expensive. So drones would actually be an alternative situation, or an alternative solution. Drones would be obviously a lot more cost effective than sending an entire helicopter and a pilot and other personnel onto to like map hotspots. So if drone technology is more prevalent, it would actually start to possibly replace helicopters in certain situations. So they aren't as frequently used just because they're really expensive.
And when they're used, it's usually just to map the location of the first level? Okay.
Yes, it's for thermal imaging.
What would be the range of the drone that you're suggesting, and like roughly how much land would that cover that you could detect fires on?
So that would really depend on the model of the drone. Theoretically, it would just the software or the models could work in whatever range. It's just limited to how the hardware of the drone. But the prototype I used has just a range of 200 meters because I just tried to keep it as inexpensive as possible. But I would, in normal commercial drones, a range of a few hundred meters and around 200 to 300 feet in the air would be typical.
Great talk, Robin. Just to answer Matt's question, I used to work on drones. This is something, that there are, you can get drones, with like 2.4 gigahertz and like 5 gigahertz, like radio frequencies that can go really far. And it's as Robin said, it actually depends on the size of the drone. So what Robin was talking about are like small drones that you can buy at Best Buy. But when you're doing stuff like that, like when firefighters want to do that, they can use like real, like aerial photography drones, which are much bigger, and they can have like ranges up to like, I don't know, hundreds and thousands of kilometers if they want to. But I mean, again, that's a cost versus, like what do they want to do with that?
Yeah.
Great talk, by the way.
Yeah, thank you.
Can I ask another quick question? In your Unity simulation, did you use AirSim or is it just pure Unity?
Just pure Unity.
Okay.
Yeah, I'm considering actually transferring to AirSim because I didn't know about it at that time. I just found out about it a few weeks ago, actually.
So AirSim is sort of experimental in Unity, so you might run into some issues. It works better in the Unreal Engine, but it should work in Unity, but it's not quite final release yet.
Yeah.
There's still time for possibly 2 more questions, maybe 3, if anyone wants to ask.
I have a question. Just like, it sounds like you constrained the problem really well. Like, like with a small DJI drone, with like, using a Raspberry Pi, it was phenomenal. But what if that wasn't a concern for the fire department? That they're like, they don't care about the cost. They're willing to use, the most expensive, like, copters with the most expensive, like, I don't know, like computers as well. What would you change?
So the first thing that comes to mind is obviously just using like bigger drones, more powerful and capable drones. I would also raise the computing power, so not use a Raspberry Pi. I know there's specific modules for computing, AI computing. I forget their name now, but they're more expensive, but they definitely have more computing power. Or I could just use straight out computers or GPUs that can do that task.
Do you think there would be any value for using maybe multiple drones that coordinate with each other to track down a fire, or look at it from maybe different angles? Or do you think you would rather have one big drone, or you would want to have like 10 small ones?
Yeah, multiple drones also have value. That process could be more efficient in detecting certain hotspots that maybe one drone can't from a certain angle. And also, some drones are limited in their airtime. So if you have multiple drones, you can do multiple runs and battery switches. So that could be useful for mapping a greater area or getting a more detailed map of a certain specific area.
So I have a question. So how do you position your drones, like in the map, like to the physical locations on Earth, to the map cameras? So do you have a special coordinates conversion stuff?
Yeah, so the drone has a GPS, so it knows where it is on a map or in the world. And then it can travel between GPS points. So you can give it a certain GPS point and it will travel to there because it has a compass module a compass module so it can orient itself. And then it could also just triangulate where that fire is. If you have two different frames, you essentially just have stereo vision. So you can triangulate the position of the fire, figure out the distance and the GPS point.
Thanks.
Yeah.
Okay, I think that's everything. Great talk. How about this? Okay, people are already clapping on mute. So I'm going to clap unmuted. That was a great talk. This is the hardest part about Zoom is clapping just doesn't feel the same. But thank you for the talk. And the next speaker is Arnie.
Hello. 1 second. Can everyone see my screen? Perfect. Yeah, so first let me just introduce myself. I'm Arnie. I'm a machine learning engineer. I have been working in personalization and NLP and actually a bunch of other things over the years. But today I'm going to be talking about something that may be a bit surprising to people that have known me for a while. I'm actually going to make a case for deep learning. And a lot of people would know me as a big deep learning skeptic for a long time. But hey, you know what? Today I'm going to be talking about why we should be using deep learning for recommender systems. I should mention that I could also give the inverse talk, but that's for another time, like why you should not use embeddings in recommender systems. But anyway, so this is going to be timed and everything. Just 1 second. Let me get started. Cool. And everything's going to be 20 seconds, so wish me luck. Cool. So recommendations. So it started with the Netflix challenge where you had a usage matrix where you were given this matrix where 1's indicated when a user liked something and 0 indicated when they didn't. And you were just given a matrix completion task of like, oh, what should we recommend to a user that they're going to like? So the classic way to do this is matrix factorization, where you take this matrix, you do SVD on it, learn like skinny like user factors and item factors matrices, you multiply them and approximate the original. You can also do something called ALS, which is solve 2 least squares problems. And you do that alternating. So that's why it's called ALS, alternating least squares. But we are in 2020. No one knows what SVD is. No one knows what factorized matrices are. So it's feed-forward neural nets. So when I said factorized matrix, it's a user embedding, item embedding. You take a dot product of them and try to approximate the original matrix with the mean squared error loss. Of course, you can make it deeper. You can, you don't do a dot product. You can add 10 layers in the middle. So that's what you do. But turns out this doesn't really work. If people have been keeping up with the literature, there was a paper, Are We Really Making Progress? At Rex's 2019, which showed that no, deep neural nets don't do as well. Well, why? Well, one of the reasons is you're approximating a problem that has a closed form solution with SGD. Like, why would you try to approximate that? So that's one. Number two, when you're doing deep neural nets, you're adding way too many parameters. And when you're trying to do SGD for a closed form solution, it's just, you're just making the problem harder than it needs to be. Anyway, those are some of the reasons why these like embedding based methods don't work. So wait, where's the case for deep learning then? Well, the case is, well, accuracy isn't everything. Now, EVAS or someone may say, why don't you try changing your regularizer in your matrix factorization? That becomes really hard because now you have to recompute everything. What about if you want to add interaction terms? It's hard. What about if you want to add new data? That's where deep learning really starts to shine, because now you can take usage embeddings, metadata embeddings, location embeddings, and again, you pass it through your magic deep neural model and then do a dot product at the end and still do the same thing. But in embedding look, in this world, this is much easier to do. So if you're curious, there's a paper on it. The other thing is, now you can do more than just matrix completion. You can also think of it as a next click prediction problem, sort of like a word to vec, and sequence aware recommendations tend to work really well, because when you're taking a user's immediate behavior into account, those behaviors really tend to work better. So how do you do that? Well, let's do word to vec. So, you can create usage streams like this. You have a user session where a user may have clicked on item 3, 27, 32, 57. You create a standard sliding window, middle word. Then you kind of do skipgram with negative sampling, create positive data, negative data. You do standard word to vec stuff, and you train your embeddings for recommendation. And there are papers that do that. These are the papers. But one thing to note is NLP hyperparameters that you use for word to vec don't tend to work well for Rex's stuff. That's a new work from a month ago, but the point is it still works. The parameters are slightly different. But yeah, you can generate sequences this way. You can also generate sequences from graphs. If you have interaction graphs of people click on item 1, then click on item 2. People click on item 7, then click on item 6. And the heavier weights show people do this more often. You can just do random walks in these graphs to create these sequences. Now, people have done that. There's a lot of papers like prot2vec and stuff like that. The other part is, once you have these user sequences, you can also incorporate other stuff like timestamps, device IDs and whatnot. And, recommendations are often time and context specific. And just doing it this way, it allows you to incorporate discrete and continuous data all in one place. And there's a really good blog post by Netflix on it. Finally, we're doing deep learning. Transfer learning, that's the big thing, because in modern deep learning, you never really start a problem from scratch. You never really start with a one-hot encoded vector. But if you have item embeddings, user embeddings, well, you have a good place to start for downstream tasks like, finding similar users or spam detection. Well, of course, you would need to do some fine-tuning, but the fact that you can do that, it's really cool. Of course, it means that you need to have a good feature store in your org, but at the same time, the fact that you can do that, it's really amazing. So this is my whirlwind 5-minute-ish talk for why you should be doing embeddings. But to recap, embedding-based recommender systems, they're not the best performing algorithm for the matrix completion task that Netflix first put out, but there's modularity. PyTorch makes it really easy to code stuff up. It allows you to redefine the problem into different kinds, like next click prediction. You can compose different kinds of data. And the fact that you can do transfer learning really helps with everything else. So that's my super fast intro to why you should be using embeddings for recommender systems. And I tried to follow 20 seconds per slide for each. So I spoke really fast, and I'll take questions now.
All right. Yeah, let's just go clap right now. So my question would be, what would you add to this talk if it was 10 minutes long?
Oh, I would just speak a lot slower.
Oh, okay.
That would be one. And I would probably focus a lot more on how would I incorporate all the metadata and everything. But yeah, in 10 minutes, I would be going over the slides much slower and explaining why the deep neural nets actually don't work as well. But everything's there.
Arnie, I have a question. Yeah, so do you think some of the problems are related to solving non-convex problems as a convex problem? Do you think that's part of why things are not working?
Actually, there's more to it. The problem, this is something I can definitely talk, for hours about. One of the problem with recommendation is it's fundamentally an interventional problem, because you're asking the question, would a user have clicked on an item that they never saw, right? And we're dealing with all these things in a correlational way. It's actually not so much convexity or non-convex. It's actually that you're not with matrix completion or like next next item recommendation, you're actually not solving the same problem. So the discrepancy just happens that the variance in your models don't actually capture the true reality. The reality might be up here, but your best model can only reach here because you're actually not even solving the same problem. So it's not so much convexity. It's just that that this is where the literature is also going towards. It's more that, can we actually try to solve the real problem? And this is very hard. Interventional stuff, and if you come to like the next Meetup about the data science like reading, we'll be talking about causality. That those kinds of things are really annoying to deal with, and recommender systems community is just starting to do that. It's not so much about convexity or non-convex stuff.
Okay, thanks.
So Arnie, I had a question related to what you just said, the causality stuff. So I'm also trying to do some kind of a recommender system taking into account causality. And I guess the way I was going to do it was using this thing called RecSim by Google. I'm just curious if you've ever used it, because I was hoping to be able to simulate behavior by building up the causes and then see what I can do about it.
Yeah, that's actually a very good place to start, but I would actually encourage you to not use that and use RecoGym.
RecoGym? Can you write that down in the chat so I can?
So RecoGym is kind of an extension of that. RecoGym is based on OpenAI's like stuff. It's actually from the Criteo dataset. 1 second, how do I do that? Let me turn this off. Am I still sharing my screen? Yeah, that's it. Cool. Yeah, so
I think I found it. Yeah.
So RecoGym is probably the best thing to try because they have a real data set and you can run real simulations. There's another one called the Open Bandit project that just came out, I think, a couple of months ago. Try these simulators for recommender systems. They tend, because RecSim is kind of like a bit dated. It's not really, keeping up to date with everything. Try those two.
Okay, cool. Thanks. Very helpful.
Yeah, so I have a rather naive question. Does how exactly would transfer learning help with, say, the cold start problem, if it does at all?
It doesn't. I mean, transfer learning, what I'm saying is it's just for other tasks completely, right? Like, let's say,
okay.
Now, you have a business problem of like detecting what should you recommend to the first user. Let's deal with the cold start problem. Well, now you don't need to start with like a one-hot encoded vector of an item. You can say, oh, I actually already know what an item embedding is from usage. So you can kind of like just start there and start to fine tune to your problems instead of like starting from scratch, which is what, that's one of the reasons why vision has, really been so, successful, and like, or deep learning has been so successful in vision. Like, it just allows you to do stuff like that. But on its own, no, it just transfer learning, just storing these embeddings, it's not going to help cold start. It just helps you solve other problems with those.
Okay, great.
It reminds me of that joke that you also talked about in the Slack from that video.
Oh, yeah.
That sounds exactly what you're talking about. I won't repeat the joke.
No, you should.
Well, I'm not good at telling jokes, but it's basically what was it? An ML model ML algorithm walks into a bar, and the bartender asks him, "What are you having?" And he says, "Whatever everybody else is having," and he gets a coaster. So, sounds like a cold start problem.
Yeah.
Can I ask, how do you deal? Like, is there any way with embeddings to have a notion of uncertainty, like maybe the recommender's not really sure about this one user scenario, and maybe the recommendation it's giving is actually super low quality, but how would we ever know because we're in some kind of rare part of the space?
That's a brilliant question, and that would have been one of the key things I would have put in a case to not use embeddings in recommender systems. And part of it is that, once you're starting to use embeddings and putting like a lot of like black box, like deep neural net methods, you really start to lose control over like, but at the same time, there are ways, people are, trying to kind of say, oh yeah, like let's use more attention-based things so that we can kind of know what the recommender was thinking, so we can kind of look at the weights. But then there's that huge argument that attention doesn't actually mean, that it knows, it doesn't really correlate with the reasoning of like why it was recommended. So no, like you do lose a lot of the like information of like, whether you lose the variance. So one of the classic things you would do in the collaborative filtering problem is you could treat it as a Bayesian linear regression problem where you keep track of all the uncertainties, and then you can only you only recommend when your mode is kind of like, or like when your graph starts to look very peaky when your variance is low. But in these kind of models, there is no you're not capturing the variance at all. So your uncertainty is like, well, I don't know, you just recommend. But to be honest, for most cases, people don't really care about that. Like I cared about that in academia a lot, coming from a Bayesian school, but the reality is when things go wrong, you just shrug.
So Arnie, I have a question. You've worked a lot on Bayesian non-parametric. So how do you think it's better for these problems rather than, say, embeddings or other deep learning techniques or classical techniques?
That's a very good question. If I thought they were better, I wouldn't be giving this talk. But at the same time, no, I mean, there is a lot of value in knowing uncertainty. Like if you're doing like Bayesian modeling, the biggest advantage is what Robin just said, that the fact that you can capture the uncertainty, that is really useful. So, when you're recommending something, exactly, you could have, you can make some good decisions like, oh, I don't want to recommend this because it may not be the best thing. But at the same time, it's hard to, sell that to the product manager, right? Like whichever org you're in. Oh, by the way, all my models will now have an uncertainty attached to it. And there's a non-zero probability that I'll not recommend anything. And they're like, why not just pick the max? I'm like, well, yeah, now we're not Bayesian anymore. So it's kind of like, so this is sort of like, one of those things that in theory, I completely agree that everything should be Bayesian and like Bayesian deep learning. And there are a lot of like Bayesian deep learning techniques here as well. But in reality, no one really uses them because it's just too slow. And Bruce can probably talk more about that and complain about Bayesian stuff.
So in recommender systems, do you need to, sorry, this is a basic question. Do you need to make the IID assumption? Because I would imagine whatever is recommended to you has something to say, or it will change what you like to see over time. So if in an extreme case, if YouTube keeps showing me cat videos, eventually I'll start clicking on it and I'll expect more cat videos. How do you think about that?
That's a brilliant question. And that is actually a whole field of like, like recommender systems where data is actually not missing. Like, so when you're looking at the usage matrix, when you see these, empty values, right? Like where, we don't know whether the user would have clicked on it or not. They're actually not missing at random. So they're not missing at, an IID kind of like, world. It's missing not at random. And how do you deal with that? That's actually kind of like built into this. So if you look at a paper called Implicit Collaborative Filtering. It's the classic paper that I've recommended a few times at the paper reading group. It's by Koren Volinsky. These are the authors, and they kind of like take advantage of the fact that the data is not IID, because the fact they kind of like use the idea that you are not clicking on something because we think you probably don't like it. So how about we use that information? And, so it's stuff like that. Like the data is definitely not IID is my whole point. And people actually leverage that information to make their models better.
I think there was also a component of like time that I mentioned, like over time, you're like our test change, or like we just watched all the good stuff. Now there is some crap. So just go do a random walk, but not completely uniform. I do think that that's where like those sequence aware at least models going to play, or like even in the in the most loose cases, as Arnie kind of mentioned, like go with that analogy with word2vec or word embeddings type of models where you look at a sequence loosely, not how we've been doing recently using transformers, but at least like it's already a way to incorporate some sort of a sequence awareness and allows you to tweak in a way the recommendation to how people have been behaving recently. No? What do you think, Arnie?
Yeah, agreed. Well, it's that is one of the main flaws of not doing sequence-aware recommender system, and something I've noticed in my jobs as well, where especially for power users who have used a product for a long time, and they suddenly want to change their interests, like they suddenly want to watch cat videos. Like the fact is, if you are not that dynamic, like if the classic matrix completion problem, because it's taking the whole, there's no temporal dynamic to it. The reality is, they're kind of stuck in that minima. Like, because you clicked on it for the last 2 years, because you never clicked on a cat video for the last 2 years, it's really hard for us to, recommend you that cat video. But sequence-aware models, they are a lot Markovian, like not really Markovian, but it's more like, you can have a short-term memory as well, like where, oh, right now you want to watch cat videos. And, even though historically you've not watched it, you can kind of like take those things into account. So yes, definitely it can help in also in like social problems, right? Like during the election, I was trying to watch some right-wing media content just to see, what's out there. It's hard to get those stuff recommended to me. I had to create a new account to get that. But yeah, like sequence-aware models are probably better for that.
With that, as a user of recommendation systems, every day, like, how do you communicate to the recommendation systems in a way that someone who, say, isn't as aware of them doesn't? Do you get what I'm saying?
Sort of. Like, how do you explain to maybe a product manager what this just did?
Yeah, or like, do you notice that you've adopted any behaviors that are different now that you understand recommendation systems on like a deep level that you don't notice in other people?
Yeah, I mean, I think I gave a talk a year ago. Like it was a very depressing talk about echo chambers and recommender systems. And you kind of have this, I guess, dread of like, why things are the way they are, but you're like, I don't see it changing kind of thing. So yeah, I guess you get more depressed now that you know how it works. But the reality is, there are ways to change it, right? There are ways to delete your history and just, have a fresh start. But the problem is it doesn't really match with the business goals of companies very often, where, yes, in a societal way, Facebook and Twitter and all the companies should let you just, get a fresh start, like if you want to. But then the problem is, well, what happens to their ad targeting? What happens to their revenue? Sure, that's a socially right thing to do, but it's a public company that needs to make money. So capitalism is to blame all the time. And yeah, also, it just gets you more depressed the more you learn about it.
It's funny, as a user also, like I'm genuinely sometimes afraid of the YouTube recommender system, because sometimes I really want to watch something but I don't want to click on it because I know it's going to mess up my whole feed next day. So just sometimes I decide not to watch it.
Yeah, like that's definitely an issue. The other thing is also you start to forgive errors of like, once like I think maybe 5 years ago, I was definitely a lot more critical of like, why am I seeing this? I'm like, oh, I totally know why I'm seeing this, and this is wrong. Like, oh yeah, I watched a lot of soccer videos, then I watched a lot of Liverpool videos, I watched a lot of like similar like players, but why am I being recommended a Manchester United like analysis? I'm like, I don't care. But I'm like, I totally know why I'm being recommended that, but it's wrong. So you definitely start to kind of feel forgiving.
So you wanted to remain in your Liverpool echo chamber?
Obviously. Why would I leave that?
It would be really nice if you could once in a while just turn off the recommender on demand and just get random videos. I know it's going to be junk, but sometimes I just want to see random videos.
Oh,
incognito mode.
You don't want to do that. Honestly, YouTube is probably fine. It just does it by most popular videos, and but I can probably reveal something now. I guess in my past job, I can say that 80% of the internet is porn and Twitter porn and Tumblr porn. So if you kind of need personalization a bit, unless you want to just scar yourself for life and just get uniform random content. It's all going to be the same.
With that, we have enough time for one more question, which Robin, you will go ask.
So Arnie, can you talk about the relationship between a recommender system and a bandit? And then at what point does it become RL? If you're thinking about a multi-step recommendation, is that map to RL directly, or is there something really different going on there?
That's a very good question. And so that's a different way of thinking about the same problem, right? Like, so when I mentioned the matrix completion problem, that's not a bandit problem. I mean, but you can think of it as, because imagine that every day, like this is the classic Yahoo News example where contextual bandits first started, where you have, let's say, 6 articles, and when you go on Yahoo News, you only have place to show 3 articles. Which 3 do you show? Now, you can frame that as a bandit problem, but you can kind of frame it like, okay, like I'm going to start experimenting by like showing some people some results, and I'm going to use them as the guinea pigs and start to like learn what is the optimal ranking of these my headline articles, right? So there are certain problems that fit really well in the contextual bandits like framework, but it really it's really when you're dealing with, you recommend something, you observe a reward, and then you act on it, right? And that's what RL really is. Well, RL, you can do like multiple, you can have multiple actions and then get a single, one reward at the end. But in bandits, you're doing one action, you get one reward. In recommendation system, in the problems that I talked about, but there's not so much bandit usage, but at the same time, in recommendations in general, bandits are used everywhere. Like, if you're trying to decide what the best ranking is, something I think I've talked to you about, like Robin, about like counterfactual evaluation or something. Those are kinds of things it just kind of like falls into that bandit framework where you will observe a reward right away. But if you're like running a Spark job at the end of the day, every day, it's not really a bandit problem. But yeah, does my mumbling sort of tell you anything?
It's always super interesting when you talk.
Cool.
Yes, totally. But so I think I could probably chat about that more, but I think we're not out of session time for this. Thanks. Awesome.
Well, that's great because we can just chat now. But first we have to do something really important, which is once again thank our speakers. These were all great talks. I'm really happy with this. And first let's go clap.